continuation of that one. So what we discussed. Okay. So here we got a quadratic equation in terms of lambda square. So here the equation is lambda power 4 minus 2 lambda square minus 8 is equal to 0. Now we are this is in the form of quadratic equation. What we said last problem as this ax square plus bx plus c is equal 0. Okay, so this is in the form of this equation ax square plus bx plus c is equal to 0. So if we compare that one, what we have here it is a is equal 1 and b is equal to how much here it is minus 2 and c is equal minus 8. So a is 1, b is minus 2 and c is equal to minus 2. And if you see that in place of x what we have here it is x is equal nothing but lambda square. So x is equal to lambda square and here it is x square is nothing but lambda square whole square lambda power 4. Then what we have which formula we are using for finding the roots. So if it is ax square plus bx plus c, then we are using the formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So this is the formula we are using for find the roots. So 2a. Then here it is just we can substitute what we chosen here in place of x as lambda square. So that one here we wrote. And next minus b. So what about b here it is? B is minus 2. In formula already here it is minus. So minus of minus 2. So it become plus. So minus into minus plus. So for that here we wrote 2 plus or minus b square is nothing but minus 2 whole square. So minus 2 whole square, this is nothing but what 4 and next minus 4ac. So minus 4 a is nothing but here it is having 1 and c is how much minus 8. So here it is minus into minus plus 4 into 8 32. So for that here simply we wrote 2 plus or minus 4 plus 32 by 2. So 2 plus or minus 32 plus 4 is 36 by 2. So simply what we get, see that 2 plus or minus square root of 36 is nothing but simply 36 by 2. And you can split this one is 2 plus 6 by 2, another one is 2 minus 6 by 2, right? So one is 2 plus 6 by 2, another one 2 minus 6 by 2. So 2 plus 6 is nothing but 8. So here we get it as 8 by 2, another one is 2 minus 6 is nothing but minus 4 by 2. So it means here it is 2 fourths and here it is 2 twos. So it means what we got it 4 and minus 2. But here it is what we have. This total one is lambda square. But we require the values of lambda. So for that, so lambda is equal to here it is square root of 4 and square root of minus 2. So square root of minus 2. So simply what we can write, so is equal square root of 4 is plus or minus 2 and next square root of minus 2. So for minus simply what we can write, this is square root of 2 into. So minus for removing that simply we can write I square. So what we'll get plus or minus root 2 I. Okay, so these are the total 4 roots. Okay, plus or minus 2 plus or minus root 2i. But what we know that lambda always must be greater than 0. So simply what we have to take, lambda is equal to and minus 2 we should not take that one, that is represents less than 0 and this is an imaginary number, lambda must be a integer. Okay, so finally what about the mean, or simply we can say that lambda is equal to 2. So this one here, so that one only we simplified here. See that lambda is equal to plus or minus 6 by 2. So we split it into two values, 2 plus 6 by 2, 2 minus 6 by 2, 8 by 2 minus 4 by 2. Next 4 minus 2. So lambda square is equal to 4 and minus 2 here we wrote it as 2i square and lambda is equal to plus or minus 2. Lambda is equal to plus or minus root 2i. So lambda greater than 0. So for that here we wrote lambda is equal to 2. So therefore the mean of x is lambda is equal to 2. Next we are going to calculate what they asked in that. So first Poisson distribution we are using. So that is nothing but t of capital X is equal small x, which is equal to e power minus lambda power x by x factorial. So this one we are using for all the problems. Here it is e power minus lambda power x by x factorial. So here what they asked, p of x less than or equal to 2, 2 or less than 2. So it means what will get 0, 1 and 2. So these are the three values we get it as per this one. So p of x is equal to 0. It means simply we have to substitute. Here it is in place of x as 0. So see here we substituted e power minus lambda power 0 by 0 factorial. Next e power minus lambda power 1 by 1 factorial. E power minus lambda square by 2 factorial. Simply we substituted in the formula different values of x. Here it is x is equal 0, and in place of here it is in place of x as 1, and here it is in place of x we substituted 2. Okay, now we are going to simplify this one. So here it is simply e power minus lambda power 0 is nothing but 1. So we left as it is e power minus lambda. Next e power minus lambda into lambda power 1 is nothing but lambda, and here it is 0 factorial is nothing but how much 1, and 1 factorial is also 1. Next 2 factorial is nothing but 2. Okay, so those things we wrote here. So anything by 1 is nothing but as it is that 1. So for that we wrote e power minus lambda, and here it is e power minus lambda into lambda. Next e power minus lambda square by 2. So we already calculated lambda is equal to how much 2. So that lambda value is substituted in this here. So e power minus 2, next e power minus 2 into 2, next e power minus 2 into 2 square by 2. So 2 square by 2 is nothing but simply here it is 2 square is nothing but 4. So 4 by 2. So here it is 2 times. So simply what we get in each and every term, which one is the common one? E power minus 2 here, e power minus 2 here, and e power minus 2 here. So if we take that one as common, what about remaining one? So if we are taking e power minus 2 as common one, 1 plus 2 plus, and next here it is 2 4 by 2 is nothing but what we got it 2. So 2 plus 2 is 4 plus 1 5. So 5 into e power minus 2, 5 e power minus 2. So into, so 5 e power minus 2. So this value we need to calculate. Okay. So see here that one or not. So 5 e power minus 2. 5 cancel, you can calculate this value 0.67. Okay. So next problem. So if you till now what we solve the problems, all those problems they gave a specific condition. By using that condition we calculated the value of lambda. But here it is in this problem what they mentioned, see here, if the mean of Poisson, if the mean of a Poisson variable is 1.8, then find p of x greater than 1, and second one p of 0 less than x less than 5. So this is x p of x greater than 1 and p of 0 less than x less than 5. How many they are asked in word notation? This is greater than symbol. So for that simply we can write in word notation as more than, or simply we can write greater than. Okay, and next here it is 0 less than x less than 5. So that one simply what we can write? Can you write that one as between? Okay, so between. So this one also we can use in word notation. Okay, this is they gave in symbolic notation. If they give in word notation more than, simply we can write greater than. And if they give between 0 less than x less than 5, so it means between 0 and 5, and here it is more than 1. So more than 1, greater than 1, between 0 and 5, 0 less than x less than 5. Here what they mentioned in that, so Poisson, so for that we have to use Poisson distribution, and what they mentioned, mean they give. The mean of a Poisson variable is how much? 1.8. And what we are representing in place of mean? So mean of a Poisson variable is lambda. So for that, lambda is equal 1.8 they give. So that one only here we wrote. See here, given mean of a Poisson variate is 1.8. So in place of mean we are writing as lambda. So lambda is equal 1.8. And next, what we have to calculate? P of x greater than 1, and already they said Poisson, so simply what we can write? P of x is equal, so e power minus lambda, lambda power x by x factorial, right? This one only we are using, so e power minus lambda, lambda power x by x factorial. So here P of x greater than 1, we don't know the value of n, so up to which one? So simply what we are using, by using some of the properties, we can write that one as 1 minus T of x less than or equal to 1. Okay, so this is the one we have to write for first problem. 1 minus T of x less than or equal to 1. It means what we'll get? So P of x is equal 0 plus T of x is equal 1. Okay, so T of x is equal to 0 plus T of x is equal to 1. So simply we have to substitute in this formula in place of x as 0 and in second one in place of x as 1. Then we get it. And next, between P 0 and 5, it means numbers we know that. Everyone knows the numbers 0, 1, 2, 3, 4, 5. So between 0 and 5 they ask. So between 0 and 5 what we have? 1, 2, 3, 4. It means P of 1 plus P of 2 plus P of 3 plus P of 4. Same formula we have to use. So first x is equal to 1, x is equal to 2, x is equal to 3 and x is equal to 4. And by simplifying that. Okay. So that one only we did here. See. So here it is, y for a Poisson distribution, the probability of x successes is just we wrote the formula and we substituted lambda value also. Okay, so you can substitute directly in the problem, or here first you can substitute and then you can write. So here it is, p of x greater than 1. So that one on what we discussed, same that one or not? 1 minus p of x less than or equal to 1. So x less than or equal to means what are the values we get? X is equal to 0, x is equal to 1. And we substituted in the formula. So in place of x as 0. So here also 0 factorial, and here it is x is equal to 1 and 1 factorial. So this complete value is 1. Why? Because anything for 0 is 1 and 0 factorial is also 1. And here it is 1 factorial is nothing but 1, right? So in these two terms, which one is the common one? E power minus lambda is the common one. So that one we wrote outside. And what are the remaining one? 1 plus, and remaining is in second term is lambda. So that one we wrote. Simply which is equal to 1 minus e power minus 1.8 into 1 plus lambda value, we know that 1.8. And we can write this one. So that is nothing but 1 minus 1 plus 1.8, 2.8 into e power 1 minus 1.8. So completed that value. Okay, so you can calculate that value. Okay, so here simply see that one we did 1 minus 2.8. So it means e power minus 1 sorry, 1 plus 1.8 is 2.8 and e power minus 1.8 as it is. So this is the probability of at least more than 1. And next, between 0 and 5. So between 0 and 5 what we have? 1, 2, 3, 4. Simply we substituted in the formula. So what is that formula? E power minus lambda, lambda for x by x factorial. So in that formula we substituted, here it is, in place of x as 1, and next in place of, so this is the formula, right? So e power minus lambda, lambda power x by x factorial. Okay, this is the formula we are using. So here it is, first x is equal to 1 we are substituting in this formula. Okay, next x is equal to 2 we are substituting. next x is equal 3 we are substituting, and next x is equal 4 we are substituting. E power minus lambda as it is. In place of x only we are substituting, nothing we did in that. Okay, in place of x first we substituted 1, and the next 2, and the next 3, and next 4. And now we are taking common terms. Simplification as your wish. No need to follow as it is what we are saying here. Okay. So directly you can substitute lambda value and using galaxy you can calculate. Okay. Or you can follow this. E power minus lambda, lambda is the common one, each and every term. So that one we took common here, and remaining terms are here. First one 1. And here lambda already we took common. 1 lambda we took common, and remaining lambda here, and 2 factorial is nothing but 2. Next, here it is lambda we took common, but here lambda cube, so 3 minus 1, 2. And next here it is having 4, so 1 lambda we took common, so 4 minus 1 is remaining 3, so 3. And 3 factorial is nothing but how much? 6. 3 into 2. Next, 4 factorial is nothing but 24. How it is? 4 into 3 into 2. Okay, into 1. So this is 24. And now we are substituting in place of lambda as 1.8. Already that one they gave in the problem. So that one we substituted here. 1.8 into e power minus 1.8. 1 plus 1.8 by 2. 1.8 whole square by 6. 1.8 whole cube by 24. Now we are we can simplify that one. Okay. So by simplifying we got these values. So finally between 0 and 5 the probability is 0.7985. Okay, so this is one model, and first 4 problems they gave condition. By using that condition we used to calculate lambda. After that we simplified what they asked. Here in this problem we didn't calculate any lambda value, directly they gave in the problem, that one we chosen here, and then we calculated what they asked. Okay, by using Poisson distribution form. Okay, and now next problem. Here it is, and here onwards problems, step problems. So it means we have to identify what information they gave in the problem. Based on that we need to apply. Okay, see here, a hospital switchboard receives an average of 4 emergency calls in a 10-minute interval. What is the probability that there are at most 2 emergency calls in a 10-minute interval? And second one, there are exactly 3 emergency calls in a 10-minute interval. Okay, so here it is. If you see that a hospital switchboard receives an average of 4 emergency calls in a 10-minute interval. So if you are taking here, we are discussing about hospitals. Okay, so like as if an accident, so immediately we will call for ambulance, or if it is any health problem issues for anyone, immediately we call to ambulance. Okay, so that information here given. So this is on average. Okay, so on an average how many calls they are getting? 4 calls. With how much time? 10 minutes. Okay, so within 10 minutes they are getting on an average 4 emergency calls. They are not saying about exactly 4. So here see that clearly, average. Okay, so on an average they are getting 4 emergency calls in a 10-minute interval. And next what they are asking, what is the probability that there are at most 2, so at most 2 emergency calls in a 10-minute interval. And next there are exactly 3 emergency calls in a 10-minute interval. So here it is, on an average 4 calls they are getting in a 10-minute interval. So what are the possibilities, what are the chances for getting at most 2? So at most 2 is nothing but simply we can write less than or equal to 2. So here it is, then what they ask, probability. So for that, T of x less than or equal to 2. So this one they ask for first of all. Okay, and next there are exactly 3 emergency calls. So exactly is nothing but what symbol we are using, equal to, and 3. And next probability we are calculating. So P of x is equal to 3. That's it. And now we are going to calculate t of x less than or equal to, another one t of x is equal to 3. Okay, so these are the two things we are calculating here. So for applying Poisson distribution, what are the requirements we need? So lambda we require, so x already we know that, so lambda we require. For lambda is nothing but what we are saying, mean, right? Average is nothing but simply what we can say, that mean. Okay, so what it represents, lambda. So what is the mean of this one? 4. Okay, so it means lambda is equal to how much? 4 calls per 10-minute interval. So 4 calls per 10 minutes. So this is they give in the problem. Okay, so lambda we know that, and simply we can here calculate t of x less than or equal to 2 and t of x is equal to 3. Okay, so now go to the drawing. Okay, now go to the solution. So here it is first given that mean lambda is equal to 4 calls per 10 minutes. This one already they gave in that. Okay, on an average. So average is nothing but mean. So that mean lambda is equal to 4 calls per 10 minutes. So lambda is equal to 4 calls. Next, we are writing the formula here for a Poisson distribution. T of capital X is equal small x is equal e power minus lambda lambda power x by x factorial. So this is the formula we wrote, and x is equal 0, 1, 2, 3 and so on. And another thing we need to remember, lambda should be greater than 0. Okay, so when you are writing the formula, obviously if you are writing this one and this one, easily you can remember that lambda is greater than 0. And first one what they ask, the probability of getting at least, so at most 2 calls, okay, in 10-minute interval. So at most is nothing but simply what we are using, less than or equal to. And the next 2 is here, 2 as it is we are writing. So p of x less than or equal to 2. So here it is less than or equal to 2 means what we'll get. So 0 onwards will always will count 0, 1, 2. So less than or equal to 2. R equal to also here. So R equal to means including 2, and less than 2 means what we'll get 1 and 0. So those things here we write. See here 0, 1 and 2. Okay. Now we are substituting in place of x as first one 0, and in place of x as 1, and in place of x as 2, and already we know the value of lambda. Okay, so here it is, see that one only we are substituting, e power minus lambda lambda power 0 by 0 factorial. And next, when x is equal to 1, so this is x is equal to 0, so simply in this formula we are substituting e power minus lambda lambda power x by x factorial. So here it is, in place of x we substituted 0, and in place of x here also same 0. Next, in place of x what we have 1, so for that in place of x we substituted 1 and 1 factorial. Next, in place of x what we have 2, so for that 2 and 2 factorial. Now we are going to simplify this one. This is nothing but how much? 1. Why? Because anything for 0 is 1 and 0 factorial is also 1. So for that here it is e power minus lambda. Next, 1 factorial is 1, lambda power 1 is lambda. So lambda e power minus lambda. Next, 2 factorial is nothing but 2, so lambda square e power minus lambda. In each and every term, which one is the common one? So e power minus lambda is the common one. So we can take that one as common. And what are the remaining one? 1 plus lambda square by 2. So these are the remaining one, right? So 1 plus lambda square by 2. So in place of lambda, so already they gave in that. So what about lambda they gave? 1.8. I think 1.8. So wherever you have lambda, you can substitute and simplify in that. Only the important thing is understanding the question what they asked and identify which one we need to calculate. So here it is, lambda is equal to how much? 4. Sorry, 4 they gave. So for that we substituted in place of lambda is 1 plus 4 plus 4 square by 2. So 16 by 2. Here we got it as 8. So that is 13 into e power minus 4. We got it as 0.2381. Next, exactly 3. So exactly 3 is nothing but P of x is equal to 3. Same, e power minus lambda, lambda power x by x factorial. So e power minus 4, 4 cube by 3 factorial is nothing but how much? 6. 3 into 2 into 1. So 3 into 2 into 1, 6. Okay. And next 4 cube. Why? Because lambda is equal to how much? 4. So in place of lambda, 4 we substituted and we calculated. So the probability of exactly 3 calls in a 10-minute interval is 0.1954. Okay. Now next problem. Same the type of one. The average, so number of phone calls per minute coming into a switchboard between 2 p.m. and 4 p.m. is 2.5. Determine the probability that during one particular minute there will be 4 or fewer. Second one, more than 6 calls. Okay, so here it is, same like as previous one. The average number of phone calls per minute coming into a switchboard between 2 p.m. and 4 p.m. There it is, they give particularly 10 minutes. Okay, 10 minutes time they give. Here it is, they are giving specific time 2 p.m. and 4 p.m. between. Okay, between 2 p.m. and 4 p.m. is 2.5. Okay, so here also same. Hospitals, the average number of phone calls per minute coming into a switchboard. It means you can take mobile. Okay, between 2 p.m. and 4 p.m. how many calls you got it? Okay, how many calls you got it on an average? 2.5. Okay, per minute. So average, here it is. So average is nothing but simply what we are saying, mean. So what they give here, clearly we can say that mean lambda. So lambda is equal to how much they give? 2.5. This one they give. Next, determine the probability that, so we have to determine the probability that during one particular minute there will be 4 or fewer. Okay, 4 or fewer. Few is nothing but some. Okay, not more than. So 4 or some, less than. Okay, so it means simply what we have to calculate, less than or equal to 4. And next, more than. So more than is nothing but, more is representing greater than. So it means what we are going to calculate, first one, 4 or fewer is nothing but p of x less than 4, and second one, p of x greater than 6. X greater than 6. Already they mentioned in the problem, lambda is equal on an average how much? 2.5 calls per minute. Okay, so that only, and simply by using Poisson distribution we can calculate it. Okay, so that is, here it is. See here, so given mean lambda is equal to 2.5 for a Poisson distribution. So this is the formula we are using, e power minus lambda, lambda power x by x factorial. So first one, 4 or fewer. So P of 4 or fewer. So that is nothing but simply what we are writing, P of x is equal to, so less than or equal to 4 none. So less than or equal to 4 is nothing but what we'll get, 0, 1, 2, 3 and 4. Okay, so P of x is equal to 0. Next, P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. Why? Because here it is having r equal to. So r equal to also mentioned, and less than 4. So r equal to, in place of r equal to we are writing equal to 4, and less than 4 means what will get, 0, 1, 2, 3. Okay, so simply we substitute P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3. So if for all these things, so already we wrote that formula. What is that? E power minus lambda, lambda power x by x factorial. So this is the formula we are using. So in place of x what we have? 0. So that one we substituted here. Next, P of x is equal to 1. It means in place of x is equal to 1. And next, in place of x is equal to 2. In place of x is equal to 3. and in place of x is equal 4. Okay, so in this formula, e power minus lambda, lambda for 0 by 0 factorial, e power minus lambda, lambda for 1 by 1 factorial, e power minus lambda, lambda square by 2 factorial, e power minus lambda, lambda cube by 3 factorial, and e power minus lambda, lambda for 4 by 4 factorial. Now we are going to simplify. So in place of this one, anything power 0 is 1 and 0 factorial is also 1. So nothing in that. So further simply we have wrote here e power minus lambda. And this is 1 factorial is nothing but 1. So lambda e power minus lambda. Next, here 2 factorial is nothing but what? 2. So for that lambda square e power minus lambda. Next, here is 3 factorial. So 3 factorial is nothing but 6. So 3 into 2 into 1. Okay, so 3 factorial is nothing but 3 into 2 into 1, 6. Next, lambda cube as it is e power minus lambda. And 4 factorial is nothing but how we are writing 4 into 3 into 2 into 1. So that is 24. So lambda for 4 by 24 e power minus lambda. Now we are going to simplify this one. So in each and every term, which one is the common one? That one we took common here. E power minus lambda is the common one. So that one we took common. So after taking the common one remaining, in first term 1, and in second term lambda, and in third term lambda square by 2, and fourth term lambda cube by 6, and fifth term lambda 4 by 24. So those things we wrote here. Okay, and now we already know that the value of lambda 2.5 calls per minute. They already gave this one in the problem. So for that we are substituting in place of lambda as 2.5. So 2.5, 2.5 whole square, 2.5 whole cube, 2.5 whole power 4 by 24. By simplifying that, so by calculating that one, we got it as 0.8912. Okay, so like this. Nothing we are doing, just we are substituting the values in the formula. Okay, only the thing is you need to identify what they asked. If they give in word notation, how to write in a symbolic notation. And next, so more than 6 calls. Okay, so more than 6 calls is nothing but 1 minus, so we don't know the value of n. So in binomial distribution, if suppose n is equal to 10 means we have two ways we can solve this one. One of the way is nothing but this one, or another way is nothing but more than 6 is nothing but simply we can calculate t of 7 plus t of 8 plus t of 9 plus t of 10. Okay, so these things also we can calculate and we can simplify, right, in binomial. But in Poisson, we can't apply this. Why? Because we don't know the value of n. So number of trials we don't know here. Okay, just we know that lambda value. Okay, so mean value we know that. We don't know about n and t. Okay, now so p of x greater than 6. Here no are equal to. So for that simply here it is we need to include. Please take care of that when you are writing this one. Okay. So with anxiety, people do the mistakes. Okay. So p of x greater than or equal to 6 they give, or just greater than 6 they give. You need to identify. Okay. So here it is greater than 6. So for that simply what we can write, 1 minus p of x less than or equal to 6. So it means r equal to means p of x is equal to 6 we wrote here, and less than 6. So less than 6 means what we'll get? 0, 1, 2, 3, 4 and 5. Right? So less than 6. So those things only here we wrote 0, 1, 2, 3, 4, 5. In place of r equal to we wrote 6. Now as usual, so here it is, you have to substitute e power minus lambda. We have to use the formula e power minus lambda, lambda for x by x factorial. So first we have to substitute in place of x as 0. Next 1, 2, 3, 4, 5. So after substituting, here it is, which one is the common one? E power minus lambda is the common in each and every term. And then we wrote remaining here, if we substitute 0, what we'll get? 1. And next lambda, lambda square by 2 factorial, lambda cube by 3 factorial, lambda for 4 by 4 factorial, lambda for 5 by 5 factorial, lambda for 6 by 6 factorial. Only this one simply. for different values of x 0, 1, 2, 3, 4, 5, 6, and we kept this one outside e power minus lambda. And already we know that lambda value, so lambda value how much they go 2.8 cos per minute. So in place of lambda we have to substitute, and by Gaussian we have to get the solution for that 2.5 again. So 1 minus e power minus 2.5, 1 plus 2.5. So wherever you have lambda, just we can substitute 2.5, and then we simplified this one 0.01416. Okay, and next, so this is general one, so first one side one, and this is also general one. So here it is what they mentioned: average number of accidents on any day on a national highway is 1.8. Okay, so here they clearly mention on average how many accidents are happening on a national highway, 1.8. Okay, so 1.8 accidents are going on a national highway on any day. Okay, they didn't ask any they didn't say that any particular day, on any day. Okay, so determine the probability. So they asked to find determine the probability. So here it is P, that the number of accidents are at least one, at most one. Okay, the number of, what are the possibilities or what are the chances for at least one accident and at most one accident. Already we said very important these two words. At least is nothing but greater than or equal to, and at most is nothing but less than or equal to, including or equal to. At least one is nothing but greater than or equal to 1. At most one is nothing but less than or equal to 1. It means what we have to calculate, phi of x greater than or equal to 1, and this is phi of x less than or equal to 1. So these two we are going to calculate. And lambda already they give. So average is nothing but simply what we are saying, mean. Okay. So on an average on a national highway, the accidents are 1.8. So that is mean lambda is equal 1.8. So that one we are representing as lambda. So lambda is equal 1.8. And next formula substitution, nothing in that. And at least one is nothing but. So greater than or equal to 1, and at most one is nothing but less than or equal to 1. So those things only we substituted here. So first what they give, on an average the number of accidents on the national highway is lambda is equal to 1.8. That one simply we wrote here in place of average, mean. And next, by Poisson distribution, P of capital X is equal small x is equal e power minus lambda, lambda for x by x factorial, where x is from 0, 1 to and so on, and lambda is greater than 0. First one, at least one. The probability of getting the number of accidents, at least one is, at least is nothing but greater than or equal to, and 1 is nothing but 1. Now we don't know the value of n, so for that there is no alternative by using sum of the probabilities, and nothing but p of x less than 1 plus p of x greater than or equal to 1 is equal to 1. Sum of all the probabilities is equal to 1. We require this value, so for that we are taking this one into right hand side. Here it is having plus, when it comes to this side minus. So that's why we wrote here p of x greater than or equal to 1 is equal to 1 minus p of x less than 1. So here not included 1. Okay, so only less than 1. So less than 1 means we have only one thing. What is that? 0. So 1 minus p of x is equal 0. So that one we are going to calculate here. So 1 minus p of x is equal 0. So 1 minus, in formula we are substituting lambda for 0 by 0 factorial is nothing but 1. So here it is, in place of this one is 1, and remaining 1 minus e power minus 1.8. So how much we got it? 0.8347. And second one, at most one accidents on a national highway on any day is p of x less than or equal to 1. So it means in place of at most what we used, less than or equal to, and 1 is 1. Okay, so p of x less than or equal to 1 means including 1. Okay, simply we can calculate. So So less than or equal to 1 means x is equal to 0 and x is equal to 1. Okay, so now here it is. See that one we wrote here, p of x is equal to 0 plus p of x is equal to 1, and we substituted in place of x as 0 and here it is in place of x as 1. Okay, next what we got it, e power minus lambda, in place of this one 1, anything power 0 is 1 and 0 factorial is 1. So and remaining here it is 1 factorial is also 1 and remaining only lambda into e power minus lambda. In these two terms, which one is the common one? E power minus lambda is the common one. That one we took common here, and by substituting 1 plus, sorry, after taking common, what we have remaining? 1 plus lambda. And lambda they give, simply we have to substitute in place of lambda as 1.8. So this value we have to substitute and then simplifying that. So here it is, e power minus 1.8 into 1 plus 1.8, that is 2.8, which is equal 0.4628. Okay, next, 2% of the items of a factory are defective. The items are packed in boxes. What is the probability that there will be 2 defective items, and second one, at least 3 defective items in a box of 100 items? So till now what we solve the problems, in those problems they give on average. So average, it means mean they give and we calculated. But here it is what they are saying. See here it is, 2% of the items of a factory are defective. It means some factory is there. Okay, some manufacturing company or factory. In that some items are products. Okay, they're manufacturing. So obviously when they are manufacturing anything, some defectives will be there. So that one they mentioned here, 2% of the items. It means 2% of the items in the sense is 2 by 100. It means if they are manufacturing 100 items, so if they are manufacturing how many items? 100 items. How many are defective one? 2 defective one. Okay, so that one they mentioned here. So number of defective items are 2 out of 100. So it means what they give? Probability they give. The probability of defective items, P is equal to 2%. So this one they mentioned in the problem. Okay. Next, the items are packed in boxes. Okay. So obviously after completion of the manufacturing, they keep in boxes. What is the probability that there will be 2 defective items? So it means 2 is nothing but x is equal to 2. So they are asking here probability. So for that, P of x is equal to 2, we have to calculate. And next, at least 3 defective items. It means at least is nothing but, simply what we have to write, greater than, and 3 is nothing but 3. So it means what we have to calculate, P of x greater than or equal to 3 we have to calculate. In a box of 100 items. Okay, it means in a box how many items they are keeping? 100 items they are keeping. So it means n is equal to how much? Number of items 100. Okay, so it means we get an idea. So n we know that, and p also we know that 2%. Okay, so 2% they give, so that is nothing but 0.02. Okay, next, these are the things we are going to calculate. So can we apply binomial distribution for this problem? We can. We can apply binomial distribution as well as Poisson distribution. Why? Because we know the value of n. N value we know that, and p value also we know that. Okay, and we can get the q value also. How will get q value? Since p plus q is equal to 1, q is equal to 1 minus p. So 1 minus 0.02. So q value also will get it. Okay. So n value we know that, p value we know that, q value we know that. So binomial distribution also we can use, and they didn't mention anywhere this is we are following as a Poisson distribution, like that they didn't mention. So we can apply binomial as well as Poisson. Anything you can apply. Okay. But for applying Poisson, what we require? Lambda we require, right? So lambda is equal. So what we said? So lambda is equal nothing but the product of number of trials into probability. So n is equal, lambda is equal, n is nothing but 100 into p is nothing but 0.02. So it means lambda is equal to how much? 2. So which is greater than 0. Okay. For applying Poisson distribution, only this one we have to do it. For applying binomial distribution, by taking these values, simply we can calculate. Okay. So in two ways we can solve this problem, either binomial or Poisson. Okay, you may get doubt. So which problem I have to use binomial and which one I have to use Poisson? Is it clear about it? So if they give previous problems, did they mention anything about n and p? No. So directly they give average, mean they give. So for that we took that one and we calculated. But in this problem they gave n value, p value. By using this we can calculate q value. So you can use binomial distribution and Poisson also we can apply. So why? Because lambda is equal to np. Just by multiplying we get lambda value. Okay. So let us see the solution. Here it is. First, given number of items n we wrote, and next the probability of defective items since p is equal to percentage 0.02 and mean. So why? Because for applying Poisson we require lambda. So that's why we calculated lambda here. Np 100 into 0.02 is equal to 2. Why Poisson distribution? Since p is very small. Okay. So what we said, when we can apply binomial distribution and when we can apply Poisson distribution. Poisson distribution is applicable for number of trials are very large and the probability is very small, which is nearer to 0. See how much probability? 0.02 probability, 0.02 possibility. Okay, so this is probability. And number of trials, how many items in that? 100 items in that. Okay, so for that we can apply Poisson distribution. Okay, if you apply binomial also, nothing will happen. Okay, so if you have patience for doing such bunch of calculations. Okay, so here it is. See that since p is very small, we are applying Poisson distribution. P of x is equal to e power minus lambda, lambda for x by x factorial, x is equal to 0, 1 to and so on, and lambda greater than 0. So here it is. First one, p of x is equal to 2. Okay, so first part they asked two defective items and second one at least 3. Okay, so p of x is equal to 2. So p of x is equal to 2 is nothing but in place of small x what we have 2 here it is. Okay, so for that we substituted in place of x as 2. So lambda square by 2 factorial and e power in place of lambda. Lambda already we calculated. Lambda is equal n into p we applied and we got it as 2. So that lambda value is substituted here. E power minus 2, 2 square by 2. Here 1, 2, 1, 2 cancel and remaining 2 into e power minus 2, 0.2706. How much easily we got it by applying Poisson distribution? See that. Same you can apply this one binomial also. Binomial, what is the formula for this? NCX, p power x, q power n minus x. So this is the binomial distribution formula we are using. So n already we know that. How much? 100. C. X already in place of x how much? 2. So for that 100 C2. And P is nothing but how much? 0.02 P. They gave already in this problem. And X is nothing but how much? 2. And next Q is nothing but 0.98. Why? Because 1 minus P. 1 minus 0.02, 0.98 and n minus x is nothing but 100 minus 2. So that is nothing but 98. See how much calculation. 100 C2 0.02 whole square into 0.98 whole power 98. Okay, so this one you can calculate. Or you can just this is see that simply how we got it here. Okay, so in values also little bit difference will be there, slight difference. Okay, so So why? Because comparing to binomial Poisson, you get the accuracy. Okay. Suppose that here it is 0.2706. Here you make it as 0.26 or 25 something. Okay. That is like this. And next second one, at least 3. So at least is nothing but greater than or equal to. So that's why simply we wrote 1 minus p of x less than 3. Here we know the value of n. If you want, you can use. So how to write? P of x is equal to 3. So 3. P of x is equal to 4 plus p of x is equal to 5 plus p of x is equal to 6 up to which one? 100. Why? Because n is equal 100. So see how much time it takes for applying. 3, 4, 5, 6, 7, 8, 9, 10, 11 till 100 you need to calculate. We can. So 3 hours it will complete. Okay. For calculating 3p of x equal 3p of x equal to 4. So for that we are using sum of the probabilities is equal to 1. By applying we are getting as 1 minus p of x less than 3. So less than 3 means 0, 1, 2. So here also same. In place of x as 0, in place of x as 1 and in place of x as 2. Or binomial also you can apply. So binomial means what will get? 100 c naught p power 0 q power n minus 0. So n is nothing but 100. So q power 100. Okay, p already this value, p value and q value with this one we can substitute. Plus next this one 100 c1. Okay, and next p power 1 and q power 99. Q power 99 plus p of x is equal to, it means this is as it is 100 c2 p square q power 98. So all these things you can calculate. Okay, so you can apply binomial or Poisson. Comparing to binomial, Poisson easily we can get. Okay, so here it is, see that how much easily we'll get the value for this. So 1 minus e power minus lambda, lambda power 0 by 0 factorial, lambda power 1 by 1 factorial, lambda square by 2 factorial. So 1 minus e power minus lambda. So 1 plus lambda square by 2. Okay, next we substituted in place of lambda as 2. So why? Because lambda we know that. So that's why we substituted in place of lambda as 2. And then 1 minus e power minus 2 into 1 plus e power 2 plus 2 square by 2. So there it is, we got it as 1 minus e power 5 e power minus 2, which is equal to 0.3233. So this is one of the example for you can apply both binomial as well as Poisson. But as per this rule, see that p is very small, which is nearer to 0, and the number of trials are large and is equal to 100. So for that we can apply Poisson, but there is no mistake, there is nothing wrong if you apply binomial also. Okay.